In this video, we'll work an example of integration by substitution. So looking at this one, it might be pretty obvious how to get started. Well, there's our inside function, x plus 1. But after we get started, it might become unclear how this proceeds. So u equals x plus 1. And if I find du, that's the differential, so this will be the derivative of x plus 1 times dx, and that derivative is 1, so 1 times dx, so du equals dx. So fine, the dx will get replaced with du, okay. The x plus 1 will get replaced with u, okay, but what's going to happen with this guy? Because when we make those replacements, there's no x here that can cancel with this x over here, so I'll go ahead and make those replacements. So I have x square root of u times du, and it might not at all be obvious, like, okay, well, we can't leave this x here. In order to find an antiderivative, we have to switch everything over to u. Maybe this u doesn't work, right? It seems to not work. We've had examples before where we have a thing that doesn't cancel and we're kind of stuck. We have to do a different substitution. So, or also we'll have examples like that in the future potentially. So some of you might be yelling at your screen, oh, it's so obvious. Why is he acting like that this is hard? But it might not be obvious. For some it's obvious, for others it's not so much. Basically, I need to take this equation and subtract 1 on both sides to get u minus 1 equals x. So u minus 1 equals x, and that is what gets replaced in for x there. So this is then the antiderivative of u minus 1 times, while we're at it, I need to remember that I can rewrite any root as an exponent, so this is u to the 1/2 power. This is basically a very algebra-heavy example. There's a lot of, you gotta use properties of exponents. You have to notice that you can use an equation to switch the variable. So it's I don't want to say it's overly difficult, but it requires you to notice several things that are not necessarily obvious. So now, I'm not ready to find the antiderivative yet. There's still too many pieces here. I need to do something else. And again, this might be obvious, but perhaps not. Basically, I need to distribute. So this u to the 1/2 power needs to multiply against this term and against that term, okay? So u times u to the 1/2 power, I'll write that over here. Sometimes this can be a bit confusing if you don't remember properties of exponents. This first factor with no exponent written, there's an implied 1 because that's one copy of u. And when you have two exponential expressions that have the same exponent and they're being multiplied, then I can add the exponents. So this is equal to u to the 3/2 power. So that's what I'll put over here. This is the antiderivative of u to the 3/2 power minus u to the 1/2 power du. Okay, and then I'll just apply the power rule to each term individually. So this is u to the 5/2 power over 5/2 minus u to the 3/2 power over 3/2 plus c. And I'm not done because I have to put the x plus 1 back in for u. This is how we defined u. And again, as before, we've made up u to help solve the problem, so it can't be in our final result. So this is 2/5 times x plus 1 to the 5/2 power minus 2/3 times x plus 1 to the 3/2 power plus c. Okay, and there we go. That's the antiderivative.